Today we're going to be factoring trinomials. So instead of doing greatest common factor, today we're looking at trinomials that don't necessarily have a greatest common factor. Some of them may once we get a little bit farther. But basically, factoring trinomials is undoing foiling. So we take two binomials like x plus 2 times x plus 3, and we multiply them out, we FOIL them. X times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. And then we'd combine like terms and end up with x squared plus 5x plus 6. So now we're going to start at this step and we're going to go backwards to the factored form x plus 2 times x plus 3. So when we think about that, I want you to think for a minute about the relationship of these numbers 2 and 3 with the numbers 5 and 6. When you add those two numbers together, you get 5. When you multiply those numbers together, you get 6. And that's because when you FOIL this out, you end up with these two like terms in the middle. So the 2x and the 3x, that adds together to give us the 5x. And then that last step, the L, 2 times 3 gives us the 6. We're going to use that relationship to help us do the factoring. So when we look at x squared plus 8x plus 15, this is going to be x something, x something. Those two numbers have to multiply to give us 15, and they have to add up to 8. So think about ways that you can multiply to get 15. We can do 1 times 15. We can do 3 times 5. 1 times 15 is not going to work, but 3 times 5 is 15. 3 plus 5 is 8. So these numbers are positive 3 and positive 5. And that is the factored form. All right, now in part B, there's a subtraction sign, so that's going to change things a little bit. We need, We need two numbers that multiply to give us 12, but this time they need to add up to a negative number. They need to add up to negative 7. So negative numbers must be involved. But in order to multiply to be positive, the only way to get a positive 12 is to do a positive times a positive or a negative times a negative. So this time we need negative times negative so that we have negative plus negative to give us that negative number. Got 1 times 12, 2 times 6, 3 times 4. I think 3 and 4 is how we're going to get there. Negative 3 and negative 4. So x minus 3, x minus 4. Now you can write these parentheses in any order. This could also be x minus 4 times x minus 3. That's absolutely correct. The first one could be x plus 5 times x plus 3. The only thing that you cannot do is stack them. If you stack the two sets of parentheses, that is not mathematically correct. We are factoring this back to the multiplication of binomials. We are not just stacking the stuff that we get. We're not just looking for stuff. We're factoring this back into the multiplication of binomials. All right, let's try C. This time we're looking for two numbers that multiply to give us negative 6 and add up to positive 5. If we're multiplying to get a negative, that means one of the numbers needs to be negative. So we got 1 times 6, 2 times 3. When you see 5, you might be tempted to do 2 and 3 because 2 plus 3 is 5, but 2 times 3 is not negative 6. So we actually need to look at this option. 1 minus 6 is negative 5. 6 minus 1 is 5. So it's a negative 1 and a positive 6. X minus 1, x plus 6. Or x plus 6, x minus 1. Just don't stack them vertically. Make sure you write them horizontally. All right, why don't you pause the video and try D on your own? Did you pause the video? Okay, we are multiplying to get -6 and adding to get -1. Ways to get 6. We can do 1 times 6 or 2 times 3. 1 and 6 aren't going to get us 1. We want 2 and -3. X plus 2, x minus 3. Now, some of you, your brains are wired in a way that when you look at this, you're like, oh, it's these numbers. And it's like it just pops into your head. And some of you, your brains don't work that way, and that's totally fine. Personally, my brain does not work that way. The only reason it's easy for me to find these numbers is that I've been doing this for a long time. I have so much practice in factoring that it's really crazy easy for me. If your brain doesn't find those numbers immediately, that is totally fine. Think about ways that you can multiply to get that multiplication number, and then from those options, find the one that works for the adding part. Okay, when we factor, we really need it to look like ax squared plus bx plus c. And right now we're doing these where a is 1, so the a really isn't there at all. But we want the x squared term to be first, then the x term, then the number. So these are not in the right order. We need to rearrange them. So this is -x squared, a -x, and a +20. When you're factoring, you really don't want a negative at the beginning. You want this to be a +1, not a -1. So here we actually do have a greatest common factor that we need to get rid of. We need to factor out -1. So -x squared divided by -1 is +x squared. -x divided by -1 is +x. 20 divided by -1 is -20. Now we have a positive plain x squared. So we're going to focus on factoring just the stuff inside the parentheses. So we are looking for two numbers that multiply to give us -20. Those same numbers need to add up to a +1. Some of you already know what it is. That's great. Some of you are looking at this like, I have no idea. If you're adding up to 1, you're looking for numbers that are really, really close together. So ways that we can multiply to get 20. We can do 1 times 20. We can do 2 times 10. 3 doesn't work. We can do 4 times 5. 5 times 4. Then we've found them all. 4 and 5 are really close to each other. So that's how we're going to end up with that 1. To get a +1, you want the bigger number to be positive. So we want a -4 and a +5. So the factored part is x minus 4, x plus 5. Don't forget, we had that -1 out in front. So our final answer is -1 times the quantity x minus 4 times the quantity x plus 5. Some people might just write this as negative parentheses, and that is fine. I do like to have a -1 in front, but if you want to just write the negative, that would be fine. Okay, why don't you pause the video and try B on your own. Okay, get this in the right order and then factor out that -1. That makes it x squared minus 5x minus 14. We're looking for two numbers that multiply to give us -14 and add up to -5. And I'll tell you right now, this does not pop into my head. So I have to think about 14. 14 is 1 times 14 or 2 times 7. Ooh, 2 and 7 would give us 5. 7 minus 2 is +5, so I can flip that around. 2 minus 7 is -5. So 2 and -7. So the parentheses are x plus 2 and x minus 7, and we have a -1 in front. All right, we are going to do about one of these. Oh my gosh, there's a lot of stuff there. When there's x and y, we're only going to do one of these. When there's x and y, Basically, this just means that we're going to have x plus something y and x either plus or minus something y. So we're going to treat this exactly the same way. We're just going to have a y involved, because if we did this x squared, something xy, something xy, y squared. So carry on kind of as normal, ignoring the y. We're looking for two numbers that multiply to give us 10. Those same numbers add up to 11. That would be 1 and 10. So our factored form would be x plus 1y and x plus 10y. So really, this is exactly the same as before. We're just sticking a y into that second term in each set of parentheses. Okay, if you want to pause the video, I'm going to do B fully. Why don't you try B on your own and then play the video and I'll show you the answer. So in this one, I found that the numbers are 3 and -4. So normally this would be x plus 3, x minus 4. But we have that y in there, so it's x plus 3y, x minus 4y. You're just sticking that y in with the second term in each of those binomials. Okay, completely factor. When you see the phrase completely factor, that means there's going to be more than one step involved. So you might notice that this doesn't look like x squared plus something else plus a number. There's a lot more going on here. So your first step is factor out a greatest common factor. What do these three terms have in common? 3, 27, and 54. It would sure be nice if we could divide all those by 3. Can we divide them all by 3? Why, yes, we can. And then find the smallest x. So the x with the smallest exponent, in this case, it's plain x. We can pull a plain x out of all of these. 3 divided by 3 is 1. X cubed divided by x is x squared. Negative 27 divided by 3 is negative 9. X squared divided by an x is an x. 54 divided by 3 is 18, and we're taking that x out. This is why we started with GCF, because that's always going to be your first step when you're factoring. Now we can focus on factoring the stuff inside. So now we're looking for two numbers that multiply to give us 18. Those same numbers need to add up to negative 9. And again, this one does not pop into my head. I can't look at this and just see what numbers this is. So I need to think about 18. We can do 1 times 18. We can do 2 times 9. We can do 3 times 6. 4 times, no, that'd be a decimal. 5, no. 6 times 3, I found them all. 3 and 6 could give us 9. 3 plus 6 is positive 9, so negative 3 and negative 6 is negative 9. So those parentheses become x minus 3, x minus 6. You just have to remember that we also have a 3x out in front of that. So pause the video and try B on your own. Okay, I can divide 4, 32, and 28 by 4. And then the smallest y is y squared, so we can pull y squared out of all of those. And then here's the thing that's left that we need to factor. So two numbers that multiply to give us 7 and add up to 8. That would be 1 and 7. Don't forget that 4y squared in front. Okay, this is a very, very, very common ACT question. Find all integers b such that the trinomial can be factored. So you are looking for two numbers that multiply to give you 16 and add up to b. So basically they're asking, how can you multiply to get positive 16? You can do 1 times 16, you can do 2 times 8, and you can do 4 times 4. You can also do negative 1 times negative 16. Write those down below. Negative 2 times negative 8, negative 4 times negative 4. Add all of those together, turn these all into adding, and see what you get. So I changed all those multiplications to additions, And these are the b values that we could end up getting.